Hello, this is Dr. Cynthia First at the University of Utah, and today I'd like to do an introduction to capacitors. Let's talk about what is capacitance and how it relates to current and charges, what are the effects of the parameters of a capacitor, and what does it do to voltage and current. A capacitor is a passive element that stores energy in the electric field. This means that it does not require an external voltage source in order to act like a capacitor, and remember that it is actually storing energy. The capacitance, which you'll remember from physics, of a parallel plate is epsilon A over D. Epsilon is the dielectric material. It is a constant epsilon naught times epsilon r. The smallest epsilon r is 1 for air, and a large epsilon r would be something like 80 for water. Plastics, glasses, etc. are very close to air. Maybe their epsilon value is about 2 or even 4, and things that are getting closer to water will be more like 80. When epsilon increases, then our capacitance increases. A is the area of the two plates. That's the part that's actually parallel between them, so as I increase that area, the capacitance increases, and as I decrease the distance of the plates, the capacitance would also increase. Capacitors affect the flow of charges. The current is the change of charge dq dt, so it's how much charge changes over a period of time. The way this works is charges flow from the positive voltage source onto the top of the capacitor. They are stored there, they get hung up there, and then they force positive charges away from the bottom plate, leaving the bottom plate negatively charged and the top plate positively charged. That creates a voltage difference, so that allows us to be able to do work. Displacement current is the current that appears between the two plates. You're more familiar with conduction current. Conduction current is actually the flow of charges, the fact that these charges are flowing or moving. That's conducting electricity. But then right here between the two plates, it looks like there should be no current because there are no charges that can move, but the electric field forcing the charges makes a kind of current that we call displacement current. It's the appearance. It acts like there's a flow of charges, even though there aren't actually charges flowing in between the two plates. Again, remember that the conduction current is calculated as the change of charge divided by time. Okay, so what does it mean when we talk about epsilon A over D? Of course, a larger A can store more charges. Epsilon means that the attraction between the two charges, or the ability to set up this strong electric field, increases with larger epsilon. And D, of course, means that it reduces the attraction between the two charges. How can we build with this? So here's a simple parallel plate capacitor, but suppose that we wanted to be able to use these as a sensor. Let's consider two metal pieces with foam in between them. If we squished them or pushed them together, we'd be changing D. That would be changing the capacitance. If we slid them back and forth, that would be changing the effective area, because the area is only this where they are overlapping. And then if we wet them or put some other material between it, we would be changing the epsilon. That's how we can use capacitors as sensors. So basically we've talked about what is capacitance and how does it relate to current and charges and the effect of epsilon A and D. In the next video, we're going to talk about what this does to current and voltage.